Okay, so in this problem, we want to find the voltage across the capacitor from time t equals 0 to t infinity. Now, the voltage across the capacitor is Vc, which is the same as the voltage at this node. So we're going to refer to the voltage across the capacitor as Vc. Now, to find Vc, an expression for Vc, we're going to use this equation, which you should have learned by now. It's V final plus V initial minus V final times e to the minus t over tau. Now, to find the initial and final conditions, Vi and Vf, we're going to now analyze the circuit at 3 different time points. We're going to find Vc at t0 minus, which is the time right before this switch is going to be flipped, Vc at 0 plus, which is the time 0 right after the switch is flipped, and Vc at time infinity, which is after the capacitor has gone to steady state after the switch is flipped. So we're going to start at finding Vc at t equals 0 minus. So at t equals 0 minus, this capacitor is going to be in steady state. It'll act like an open circuit, so we're only concerned with this circuit right here. Now this circuit, Vc, we can find with a simple voltage divider. And since Vc is the voltage at this node, we just need to find the voltage across the 3K. So we're going to have 12 volts times 3 over 6 plus 3, which equals 36 ninths, or 4 volts, which means Vc at time 0 minus is 4 volts. Now, because we know that voltage cannot change instantaneously after the switch is flipped, Vc will remain at 4 volts at t equals 0 plus. Now t equals 0 plus, this is going to be our initial condition because this is from time 0 to infinity as the capacitor is changing. So we're really only concerned with t equals 0 plus. We'll just say that's equal to V initial. Now we're going to find Vc at t equals infinity after the capacitor has again gone to steady state and after the switch has been flipped. So our circuit's going to look like this at that point. Now Vc on this circuit is just going to be 12 volts because since this is not a completed circuit, no current's flowing through the 6K, which means it's the same voltage all the way through, 12 volts. So Vc equals 12 volts. And this is also our V final. Now all we need to do to solve this equation is to find tau. Now tau is going to be equal to our resistance times the capacitance. Now the capacitance is given right here, but the resistance is a little trickier. This is the resistance the capacitor sees as it's in a transient state, which means we're actually going to find the R Thevenin seen by the capacitor after the switch is flipped, which basically looks like this. So our capacitor is here. Here's the 6K, which means our Thevenin is just going to be 6K, which means our tau is just going to equal 6K times 100 microfarads, which equals 0.6 seconds. So our final equation will look like this. Vc of t is going to equal V final, which is 12 volts, plus V initial minus V final, which is negative 8 volts, times e to the minus t over 0.6. And that is our expression for our voltage across our capacitor from time t0 to t infinity.